Ladies and gentlemen, warm welcome to our webinar on UWB technologies and asset tracking, hosted by Navigine and our key UWB partner, Noccela. We are delighted that you join us today as we dive deeper into the world of ultra-wideband and its transformative impact on asset tracking. In a rapidly evolving technological landscape, indoor positioning and asset tracking have become critical components for businesses across various industries, providing high level of accuracy and reliability demanded by modern-day challenges. There are various technologies that are used to extend GPS indoors, and one of them is UWB. UWB technology has emerged as a game changer, offering unparalleled precision and robustness. Our webinar is hosted by Navigine and Noccela. Noccela is one of the leading vendors of UWB hardware for IoT and has a highly skilled team of professionals who provide their customers with the top-of-the-market asset tracking technology. Noccela offers to the market unique proprietary technology. They call it high-performance ranging, based on UWB. Some of the major benefits are centimeter level of accuracy, the market best beacon coverage, and the least interference with other technologies and external factors. The competitive edge from the financial point of view, which is also important, is been seen in cases where there is a large area with a lot of assets to be digitalized. Navigine is a provider of indoor positioning and tracking solution, offering cutting-edge technologies to enhance navigation, asset tracking, and analytics in indoor environments. So, we are a software company, and we work with the hardware partners with Noccela and provide for our clients turnkey solution in indoor positioning and asset tracking. Now, let me introduce our stellar team of today's speakers. I will start with Tuukka, who is CEO at Noccela, Martina, sales engineer at Noccela, and Margarita, partner manager at Navigine. Today, together we will illuminate the potential of UWB technologies, show success stories, and discuss the challenges and opportunities associated with implementing UWB systems. During the webinar, please feel free to ask us provoking questions in the chat and exchange valuable insights with your peers. We extend our gratitude to our partner, Noccela, Tuukka, and Martina, for their invaluable support in making this webinar possible. So, thank you, and let the webinar begin. Now I will turn it over to Tuukka, who will tell you more about UWB technologies and its values for industries.
Hello, thank you, Alex. Good morning, good day, good afternoon for everybody. So let's first take a look on a little bit what Noccela is doing and how we see the world, what is our role in that. So our slogan, making the real world smarter, that means that we are really able to digitalize, making really pure digital solutions and connecting the real life, the real world that we are in, together with cloud and other computer services. We are working in various fields. Here on the left side, you may find our strategy in a nutshell. First, we have on the left side, we have efficiency retail operations. So that means that we are working in retail. We are working in shops, in supermarkets and malls and that kind of environments. We do have different kind of end-to-end solutions there, meaning loss prevention, for example, or even retail analytics solutions. The key or the common name for all of these is that they are all based on cloud-based ultra-wideband technology. Then on the right side, you see position as a service, another division where we are working for industries and logistics, different kind of games, sports, and well-being, which is, by the way, a very fast-growing segment. And of course, smartphone indoor navigation with utilizing ultra-wideband, which is for sure one of the hot things for the coming years for ultra-wideband. We started already 2014. So we were one of the first companies making commercial ultra-wideband solutions. Since then, we have installed some roughly 100 projects in different countries for different environments. Some examples and real photos where we work. So we have logistics cases quite a lot. Heavy industry. Heavy industry means really like, for example, wood processing, where you have very heavy machines and the level of automation is quite high, but the environment is very tricky. That's a typical place where our system, our technology can really bring something new to your operation. Yeah, and then different kind of manufacturing, like assembly operations, lean manufacturing solutions is a very fast-growing field. Different kind of, for example, tool management, so that the customer factories know all the time what is the status of different tools and where they are, if they're calibrated or not, or this kind of who was using the tool last time, and different kind of solutions around that. And then we have here a picture of the indoor navigation solution. That means that ultra-wideband is known for very accurate positioning. And at the same time, we all know that our smartphones, whether it's Android or iPhone, they are more and more carrying the ultra-wideband chip inside them. And that chip is in fact exactly the same what we are using in our systems. So that means that we are able to make networks, ultra-wideband networks, which are tracking assets, but at the same time, we are able to support different kind of smartphone applications, smartphone navigation, and these kind of things. The reason why we are here today with our partner Navigine is that we are specialists in ultra-wideband, and especially large, very demanding ultra-wideband solutions. And we are not even trying to be the experts of every field, and that's why we need partners. And for us, Navigine is a very valuable partner. They are specializing in manufacturing, industry, in logistics, and that's why where we can combine then our expertise with the real life understanding what the customer problem is that Navigine has. And so, for example, here, this is another customer of ours. This is a soccer game event happening in Europe. So, example of how various applications we can have. If you can track a soccer player, you can also track many other things. If you think about the environment, the speed, and accuracy requirement, number of tags, and etc. So this is a nice application we have. We are providing the data for our customer, who is then having this actual customer interface and applications for the soccer players. So Noccela is proceeding with different kind of partners to the market. And let's take a quick look on how the ultra-wideband system works. What are the critical components of that? Here in the middle, we have tags. So a tag can be many kinds. For example, the most critical component is the circuit board inside, quite small, and all the rest is the powering and the use case specific requirements, like the size or the shape or color, and all this can be all that depends on the customer use case. There are some examples of the tags, our, let's say, standard products. Industrial tag with extremely light LED, for example. For search and find use case, you can utilize the LED like a find me. It blinks the LED on to make the workers' time more efficient. Or we have this kind of ID batch tag there. The tags are connected with the ultra-wideband radio to the beacon. Here are some examples of our beacons. And for us, very, very important factor is that how large area we can cover with one beacon. So just to give you a rough idea, the soccer field that you just saw, that is with 16 ultra-wideband beacons. So that means 500 square meter per one beacon. That is the reason why we are very scalable. You can make large systems based on our solutions because the cost doesn't get too high. And still the infrastructure, the installation and all this is very smooth process. So we are experts in large ultra-wideband installations and in let's say critical environments, very heavy stuff what we do mostly. From the beacons, the information goes to the PoE switches and then to the router, and from the router to the cloud. So our systems can be fully cloud-based. Simple with 4G, 5G router to the cloud, and you can install your system very quickly. Of course, we can also have edge computing, we can have on-premise computing, no problem at all. Typically, when you can do things in cloud, you can also do them locally. So, but this is all designed to make your start, to make your jump to this new ride as smooth and fast as possible. Because we can do even the demo or pilot based on cloud-based, but when the production exactly starts, we go on-premise computing. From Noccela Cloud, the data goes through APIs to Noccela and user applications or third-party systems. So again, very important link to Navigine. This is where the interface with Navigine goes. It's this API. And through this way of cooperating, we can have, let's say, we can focus on which we do the best, the actual ultra-wideband solution and the network on your site where you want to solve some critical problem. And Navigine can bring their expertise on the software IoT side. So, Martina, would you like to take next couple of slides and tell us a bit more about ultra-wideband technology?
Yes, thank you, Tuukka. First of all, can you hear me? Perfect. Yes, so let me start with why ultra-wideband for real-time location systems. That's where I'll start. The fundamental reason is basically the distance measurement technique we use called time of flight. So let me also explain the pictures here because I'll be talking and then you will lose track. The first picture shows a typical beacon installation in a factory. The second one as well, so the beacon is clearer there. So usually we install on the roofs as well as the walls, which communicates with the moving tags. So the third picture shows that we are tracking with a tag or a crane's hook. So this crane's hook is moving in a large area, moving assets from one place to another all the time. So that is how we derive that where the assets are moving from the hook. So that data is sent through the portals to analytics platform like Navigine, where they can perform all the analytics. Yes. So in real-time location systems, what we usually do in hardware perspective, the beacons, multiple beacons work together, performing triangulation on the tag, measuring distances between the beacon itself and the tag. That is how they pinpoint the position of the tag in real time, giving out the data of X, Y, Z coordinates based on the known coordinates of the beacons. That's how an RTLS system works. So when it comes to ultra-wideband, we use the method to measure these distances, time of flight. In time of flight, what we basically do is measuring the time taken for a signal to propagate to a target device and back. In this case, to send a message to one, let's say from beacon to the tag, and the acknowledgement message back from the tag to the beacon. Whereas in other technologies, they're more extensively using the measurement of the strength of the received signal with the value of RSSI. RSSI in long version is received signals strength indicator. So in this case, when the received signals strength gives out the information how far it has been propagating, this is drastically obstructed by the environment's obstacles. For example, there are no environments without any obstacles, such as human body to start with, furniture, walls, and even columns in factories, definitely the columns. So when one uses a RSSI technique to measure the distances, often it's the wrong the value, which gives out the wrong, or not wrong, maybe less accurate position. Whereas RSSI is, when it comes to time of flight method, the signal's strength is it's irrelevant for us. We are basically using a stopwatch to measure how long it has taken. That is why ultra-wideband is the most accurate for positioning system. And then we can talk about the next challenge, interference. Ultra-wideband has the least interference by other devices and technologies because our spectrum is least overlapped with other devices and technologies, unlike other technologies. So we are pretty much carefree regarding interference by other external factors. But then again, there are our own interference that every technologies has. For example, the multipath interference all technologies are facing. But then again, we also use RSSI values to filter out all the weak signals, and we use the strong original signals that way to determine the right distances and derive the positions. That is why ultra-wideband is the best technology when it comes to real-time location systems. It is made for real-time location systems, whereas other technologies are just derived for the positioning purpose. And then we can move on to the next slide, where I am explaining why Noccela is the best in the ultra-wideband industry. That is because of the positioning algorithm we use in our cloud, which is called high performance ranging, in short HPR, which is pretty known in the industry already, I'm guessing, among our partners, and performs very well. So to explain its performance, I have these diagrams, a couple of diagrams that explains the performance in terms of the coverage per beacon, the number of tags that a single radio area can handle, meaning tag capacity, the accuracy of the positioning, as well as the battery life of the tracking devices. So in the left-hand side, the comparison is between the coverage and the tag capacity. So in these diagrams, the red color, the more it's red, the worse the performance is, whereas green is best in terms of performance. That's what the diagrams illustrate. So in the ultra-wideband industry, there are a couple of extensively used communication protocols, which are two-way ranging and time difference of arrival. In short terms, TWR and TDOA. So we are comparing our HPR's performance in comparison to those two, which is extensively used by our competitors. So again, in the left-hand side, TWR performs best in coverage, whereas it is compromising the number of tags it can handle to the least. Whereas TDOA performs better in the number of tags, and it has the worst coverage. So with HPR, we have managed to compromise to the best performance. We have the best coverage as well as the best number of tags that UWB can handle. So we have come to that point. And on the right-hand side, yeah, these having trouble hearing my voice. Is my voice breaking?
Now it's good. Now it's good.
Okay, great, thanks. So yeah, right-hand side, the diagram is showing that the TWR has the best accuracy, whereas TDOA has the least for its own reasons. Maybe we don't have time to explain all those, but the point being that HPR has achieved the best, coming close to TWR performance in accuracy as well. And the battery life, TDOA performs the best battery life, whereas TWR has the, let's say, worse. But we have compromised to a good performance there as well. So in practice, the performance is specifically, we have a battery life of 1 to 5 years, depending on the use case. For example, the tags are 24 hours at work in 24-hour factories, active factories. And if they're constantly giving out the positioning every second, typically we use 1 hertz of sampling, location sampling. So it still has a 1 year of battery life. And less it's used, it goes up to 5 years. And per beacon coverage is 500 square meters. We have come to that. That's the best in the market. And our positioning accuracy record is 2 centimeter accuracy at a moving speed of 60 kilometers per hour. And per beacon coverage, we are simultaneously following or giving out the position of 896 active tags simultaneously, which is pretty good. And figuratively, it's limitless amount of tags when it comes to in practice, when a site has more than 4 beacons, goes up to 6, 10, and then up to 50, let's say, then it becomes limitless. And of course, although we are not saying we have TWR, we do have two-way communication as well. So we do over-the-air updates, and we do the remote controlling of the tags as well. We can do that. But the most important benefit I want to tell you about is that Whatever accuracy our clients and the partners require, we can simply give that by putting the right amount of beacons, adjusting the beacons. More accuracy you want, more beacons, less accuracy you want, we put less beacons. So that's as simple as that. And also we have overcome challenges, industrial challenges with the same logic. More beacons you put, the challenges can be overcome. And vice versa. I can show you that with the next slide. This first example, I have two examples. One is logistics center. This is a very popular use case among our partners and clients. So typically logistics centers are clean, open, and the roofs are very high. Typically 8 meters to 12 meters high. In this particular example, this is one of our clients. We have covered 12,000 square meters with just 34 to 36 beacons, which is 350 square meters per beacon. And we have installed the beacons 12 meters high. So the point being, the higher the beacons are, better the coverage is as well. Also, this site performs at a 40 centimeter accuracy, which is the required accuracy by the customer. So we don't have to overdo anything. But just in case the customer requires, let's say, 20 centimeter accuracy, the simplest thing is to do is just throw in 6 or 7 more beacons, and we have achieved 20 centimeter accuracy. And in the next example is heavy industrial. Tuukka talked about this a little. In this example, I would like to talk about the challenges that real-time location systems face, which is the sites with a lot of metallic presence. Almost all the radio technologies are facing these reflections as a problem in this kind of environment. But even in this case, when it comes to the regions where there is a lot of metallic machinery and pipes and so on, it's just a matter of installing the right population of the beacons. For example, exactly in an environment as shown in the picture, we would go down to 100 square meters per beacon. But of course, the whole site typically is not like metallic like this. There are areas like, I'm not sure if I can show the mouse point here. In the blueprint here, there are areas that is not really metallic, there is no machines there. In that case, we can even adjust the beacon population to be less dense than on top of the machines. That's how we easily adjust the number of beacons in different areas, even in the same site. So it's pretty easy. And also I would like to point out that Noccela's pricing model is performance oriented than the number of hardware oriented. So more beacons doesn't really mean more expensive. We do the pricing per square meter. So that is how it is regulated, and the number of beacons become irrelevant to that pricing model as well. Yes, that is about how ultra-wideband performs, especially Noccela. And over to you, Rita.
Yes, Martina, thank you a lot. Thanks, Martina, Tuukka. Thank you for an amazing and very, very informative overview of your system of Noccela hardware. It was short, precise, very, very to the point, and providing all the necessary information that we and our audience is interested in. So now I want to talk more about Navigine. and what we've been doing on the market so far. So Navigine is a global provider of integrated positioning technologies. The company has a 10-year history of enabling advanced wayfinding and asset tracking solutions. Over the years, we have covered more than 3,000 locations worldwide, and we have developed 2 key products. The first product that has actually kickstarted the development of the company is the mobile software development kit to enable indoor navigation, wayfinding, routing to a particular point of interest inside a building that is enabled in the mobile applications. And the second solution is a web platform for asset tracking, basically real-time asset tracking, the capabilities to do advanced reports. The team has been continuously expanding our global partner network and worked rigorously on expanding our presence in different parts of the world. As you can see, we have strong connections with partners from Europe, United States, Middle East, Southeast Asia, India, Europe, and also Latin America. And Noccela here is one of our key partners in the ultra-wideband field. Let me explain why. So Navigine is a software vendor. We do not manufacture any hardware, and for that reason, it is really important for us to have strong connections with hardware vendors that provide different technologies, ultra-wideband, Bluetooth, Bluetooth plus angle of arrival, to provide end-to-end solutions to our customers worldwide so that they fit the exact requirements of each project. Our solutions actually cater to a very diverse range of industries. Some of them are mentioned on these slides. Those are healthcare, warehousing, construction, manufacturing. We can also do museums, offices. Sometimes we've also covered retail sector. But truth be told, we are not really limited by the vertical in which we are working in. We are mostly limited by the exact technologies in some cases, because not each and every building and use case is unique, and not for all the cases the technologies that are currently available on the market can be basically can be a good fit. So now moving on, and let's talk about what it is that we have to offer together with Noccela, and that is the Navigine asset tracking solution. So what we are offering is a web-based platform that allows to effectively address workflow optimization, safety, and operations transparency objectives. So here, if we're talking about the ultra-wideband technology and real-time monitoring, visualization of each and every item or asset is on the shop floor, we are talking about the accuracy and precision of below or roughly 20 centimeters. It depends a lot on the location, on the topology of the building, but roughly we're getting from 20 centimeters to the worst case scenario is 1 meter. So aside from just seeing that each of the items are on the shop floor, we are also able to map the whole area and divide it into zones. This is called the geofencing part. So for the geofencing, we have a separate tool that we assign to each zone an area inside on the map, a particular zone. And once we get a movement detected in, or let's say someone moves from one zone to another, we send a notification that appears in the right top corner of the platform. I'll cover that a little bit later on. What we also can do, we can send pop-up notifications regarding various types of accidents that happen inside at the location, and highlight the particular the particular instances that we need to act fast on the situation. Let's say some SOS situations. Then aside from that, I know that mainly we are targeting the indoor spaces, but we are not really limited here. Navigine can also go beyond the indoor area, and we can go to the outdoors spaces as well. Thus, inside the platform, we'll be able to see the indoor map and the outdoor map. And on top of that, those maps can come in two formats. Basically, the 2D model, which you can see on the picture at the very front of the slide, and also the 3D model, in which we are also able to do the XYZ localization of the asset. That comes really handy then we're talking about, let's say, palette tracking. Now let's move on to talking about deeper about on the features, key features of the platform. So here, the platform is actually divided into several tabs that you can see here on the very top of the platform. The first one is the online tracking tab. Here, aside from just seeing how and visualizing how each and every object is moving in real time, what we can also do is search for a particular item on the shop floor and understand in which zone something is at any given point in time. And in addition, let's say we have many workers. Let's say that is in some oil and gas plant. We have many workers. They're doing each worker is doing their own job, but in general they are divided by groups based on the tasks that they are assigned to do. So in order to prevent the operators to just looking at these many objects moving all the time at a shop floor, we can divide those workers into groups based on the assigned tasks. And based on that, we can filter out them and easily locate each and every worker on the shop floor. Another set of features that we are also providing is the notifications. So here we are talking about the ability which is based on the geofencing feature. So remember, we have the zone, we have objects moving from zone to zone, and once someone is crossing the zone border, or let's say they are entering the zone that they are not assigned to do, they have no, they are basically restricted from entering the zone. Or let's say someone is staying inside the zone for too long. All of those instances can be picked up by the platform, and a notification will pop up in the right top corner of the platform notifying us basically that's an event like this has happened. And of course, it is very good to just get an understanding of there is someone or something is at any given point in time, get notifications, but all those things are happening right now. So in case we did not get on time, let's say, or we do want to see the whole picture of how and what is happening on inside of our building, what inside the platform we also can do is build reports based on the movement data that is being sent to the platform, and then further is accumulated inside the server. So those reports come in various forms. Those can be heat maps, those can be track history, workday picture, for example. We can also get we can also get reports based on all the notification that has been popping up in the if you probably already remember, in the right top corner of the platform. So all those are available in the system. They can be customized and based on the timeline that we want to take a look at. Those reports can also be exported either in the PNG format or in XLS format. And that's how we shown and making the operations more transparent for the management, for the and for the users of the system. To give you a better understanding of the parts of which the end-to-end solution consists of. So this is how the asset tracking architecture looks like now, and all of these components are extremely important for the system to work and for the solution to be implemented. So as you can see, we start with the infrastructure. Infrastructure is extremely important. That is by infrastructure, what I mean is basically the Noccela hardware devices. It consists of two parts. The first one is the stationary part. These are the Noccela beacons. And the second part is the mobile component. It can come in various types and forms. I believe you have already seen, and Noccela was very concise about what they are offering in terms of their form factors and tags. So here we are talking about two components, once again, stationary and mobile. And then the very third component that is important, that is the Navigine platform, that is a software layer to visualize and analyze the incoming data from the devices, and then basically see how everything is, what is exactly going on in the digital, in the physical world, but in the digital world. And the last thing, the very last thing that we wanted to cover today is a little deep dive into what we've done so far with Noccela. Recently, we have been working on a project, and this one was connected and implemented in a warehouse. So to give you a brief idea, this is an area of 1,000 square meters. We had to track 200 members of staff. And what we've done there is basically we needed to understand whether the staff members are staying in the assigned zones during the workday. And once the workday was over, we needed to provide analytics on all of the movements of the staff and be very, very transparent about the operations taking place, because that was affecting the basically the key KPIs of those workers. So in the end, what we've done there, we've enabled the real-time monitoring of staff through the whole workday. Then we've also provided the history, basically the track history report that showed how everyone was moving from one zone to another. And last but not least, we've also added a top layer for the operators who are managing the workers to see then someone is staying for too long outside of the assigned zone. That was actually the very first part of the project, and we've also had another KPI for us. And Martina, would you take the floor now and basically describe what we've done next for the second stage?
Sure. Thank you, Rita. Yes, so this particular use case is an extended version of this operator KPIs. So in the same warehouse, one of the identified bottlenecks in the whole operations, production operations that the organization have identified is the material pickers job taking too long. So the manufacturing process had to be delayed time to time. Well, often enough that they had to go to asking us for help. So in this case, what they do is all the picking personnel that enters the warehouse for accepting a picking job. They would enter. When they enter, we would start tracking from the entrance, and then we store their whole path that they have taken. We will save the data of the location and the path in real time, as well as keep it in historical data instantaneously until they go to the shelf and pick the material. So when they all pick the material, it is common practice already that they use a mobile QR code reader. So when they beep that, the picking job is registered as picked. At the same time, they would send a trigger to Navigine system to map the historical location path that the worker has taken and will be taken returning back to the place. That data would be mapped to the job, and those historical data over a period of time will be analyzed to improve the KPIs. So that's the solution they have gone to, and this real fact-based data is the value that we are giving to the organization, rather than blindly trying to do things to solve their problem. And of course, the extension of that solution is that tracking of the pallets as well. The previous incident use case I told you about is for the material that actually cannot be tracked with a tag, which is not practical. So there are a type of materials as well that comes in pallets. So in that case, we would tag the pallets with trackers and do the same tracking of the whole pallet moving throughout, starting from the warehouse. And that's where the tag is getting attached to the pallet, and then when they move from one phase to another through the production process, we will be tracking its location, and based on the location and the zones they enter, we would give the KPIs out of how long it takes idle, stays idle or in operation. Those kind of very specific data we could give out in different zones. We do have those kind of idle time tracking. For example, the tags would go to sleep after a minute if it's not moving. So that's when we know, okay, this product is staying idle now. So it's not being used, and maybe there's a wasted time there. So all the data like that is given out to Navigine platform, and the customers are using that data pretty effectively. Yes.
Yes, Martina, thank you very much for explaining the second stage of the project. So that is all for the speaking part from us. Now we are moving forward to the Q&A session, and we are ready to answer the questions. I've noticed that we have many questions in the chat. And now let's start.
Please.
Yeah.
Let me again jump here and handle the Q&A session. I assume you're not against that. I listed all the questions that we have now in the chat and structured them. Let's start from the UWB specific. Let's say it like this. Our attendees is interested. The first question is, what is the UWB frequency spectrum? Does it interfere with Wi-Fi? Tuko, I think this question for you or Martina.
Okay, I can answer that question. So the UWB spectrum commercially in use is varying between 3.5 gigahertz to 8 gigahertz, and there are several channels in there. And yes, Wi-Fi 6 is interfering with our channel 5, which is in 6.5 gigahertz. But we are already moving to channel 9, which is the most trending jump of the of the channels in UWB, which is also mobile phone compatible channel. So yes, we are already moving to channel 9, which is 8 gigahertz, which will not interfere with Wi-Fi 6. But so far, Wi-Fi 6 all over the world, maybe only few places already have Wi-Fi 6 active. So we haven't yet encountered with a single case of Wi-Fi 6 interfering with ours. We're good to go.
Okay, thank you. The next question is, are there any regulatory consideration or restrictions to be aware of when deploying UWB-based positioning and tracking system? It's an interesting question. I know that in some countries they do have some restrictions.
Yeah, Martina, maybe you can continue.
Yes. Some regions have restrictions for different channels. So the most extensively used channel is channel 5, which is again in 6.5 gigahertz. For example, in Japan, it is not allowed to be used. I think it is interfering with some kind of other technology they're using, maybe for security. Not sure what the reason is, but that is not allowed. So that is why channel 9 is, well, we do have options to jump to different channels, and our hardware suppliers are very, very progressive in that sense, that they are providing us with the right hardware, the radio chip in time, even before the problem starts. So we are already in solving those problems. Otherwise, we don't have particular regulations or restrictions in that we have encountered. Otherwise, yeah.
Okay, good. And some questions about your ranging technology, technique. Is it a proprietary ranging solution? Is it a FIRA compliant one?
Yeah. So when we go to smartphones and indoor navigation with smartphones, there will be, let's say, global standards. FIRA is the organization working on those mostly, and for sure we are complying with those. And when we are talking about asset tracking in isolated areas, then it's then we are using as much as possible our own let's say algorithms to be more efficient there. So yes, FIRA, we are following those regulations and standards.
And I assume
which by the way will be more and more, which is good for the whole industry. Yes.
And I assume that your ranging solution is better than the FIRA compliant one. No?
In fact, how we do it is that we are making sure that we are FIRA compliant, but we get the benefits from our own development that we have been doing very long time, 9 years already. So it's not the conflicting always. It's not the black or white. It's also that we can be FIRA compliant, but still having our own input there. That's how it will be, by the way.
Great. And I assume that you not only measure the distance, the range, but we also could do a payload, for example, beacon battery status, and manage the hardware based on the signals. Yeah. So you have an option that beacons transfer. It's not a beacon text. They transfer the battery status to the cloud, and from the cloud we could manage it.
Yes. So yeah, there was a very good question about that. There was a question about the battery life and if it's monitored. Yes, battery life, Martina mentioned, from 1 to 5 years, and on average we are in 3 to 4 if we take our customer space fully. And the battery life, what the tag is in fact reporting, typically once a second, but can be 16 hertz or something like that as well. But typically 1 hertz is our standard. It's reporting the X, Y, Z coordinates. So we are always having also the Z coordinate, by the way, and the battery status as well. So battery lifetime is not only that how long it's also that how you can manage that. And we have a full battery monitoring system for each and every customer.
Mm-hmm. And I think the most challenging question of this hardware part is, are there any specific challenges or limitations associated with implementing UWB-based indoor positioning and asset tracking systems?
Yeah, I also saw that question. That was that was a good one. What are the limitations? So something that that how to answer that. I was thinking about that. There must be a tag, and sometimes that's a limitation. Sometimes we would like to track something which we cannot have attached tag with, and so there will be always a physical tag with ultra-wideband radio. And where the huge opportunity for all of us here in the industry is that when the smartphones will work as a tag, then we don't need to tag people anymore in that sense to get the same benefits. So one thing I could come up with this is that you must have a tag, and in some environments it's a challenge to fix the tag to asset very small or something like that. But otherwise, usually we can work on we have been working with many different projects, different kinds, and always found a solution.
Yeah, and I think from the client perspective, it's also very important to align expectation with what hardware could deliver, because sometimes the customers, they want something very unique, which is not impossible, but it's very hard to reach. And it's I think that it's great. It would be great that if any project will start from a small POC. So when you want to implement some UWB-based asset tracking indoor positioning technology, it's better to start from a small area, understand all the limitation, and then scale. If you do it step by step, you will know all the limitation and challenges, and it will be not surprising you when you decide to make it like in 10 warehouses. That's very important to start from something small and scale it step by step. So then you will understand all the challenges and you know how to eliminate them. It's important. Okay, let's move further. It's an easy one. Is it possible to use some other cloud, e.g., for example, Amazon cloud? Yeah, I think of course it's possible. Any cloud and any virtual machine, as well as Martina mentioned, it's possible to put everything in the security perimeter of a client, which could also slightly improve the latency performance of the system.
Yes.
What is the lag between movement and position resolution in the system approximately? And the second question is, what is the accuracy of UWB-based systems?
Yeah, the latency, standard latency, what we have in our cloud-based system is 30 milliseconds, 30. So it's very fast. When we do demos and actual systems with our customers, you can show with your hands like this, and customer is always surprised that, oh, it's really fast. So ultra-wideband, the low latency is one of the key benefits of ultra-wideband technology.
So this low latency means that technically it could be even used for control loop. Yeah?
Yes, correct. Different kind of alarms and this kind of control machine automation is possible with ultra-wideband.
And what about accuracy? So what is the highest accuracy achievable, and what is like a good one?
Yes. Accuracy, our philosophy is that we don't propose an overkill systems, so that we can have, for example, this logistics center you saw photograph. In some areas, the accuracy is something like 20 centimeters. And in some areas, it's 60, 80 centimeters, depending on the expectation of the customer. Typically, it goes so that when we get the area and we understand the use case, we design the network, and then so that it's to the expectation of the customer. The highest what we have seen in our system is 3 centimeters. That was it in the presentation. But typically 10 centimeters, something like this, it's pretty easy to achieve. But when we go to industry, we have more obstacles, metal, wood, and these kind of things, then it becomes very expensive to have really accurate system. So it's always a little bit a choice between the cost and what is the sweet spot to find between where the accuracy really adds value.
Yeah, it's a trade-off, always.
Trade-off, yes, correct. Yes, exactly, trade-off. And I would say on average, we are in industry, we are talking about 80 centimeters, 50 to 80 centimeters, where you can usually find the sweet spot of compared to the cost, compared to the value that the system generates.
Just one more question about we mentioned the control loop, and Lorenzo asked us, do you have any cases positioning a mobile robot, and what is the size and the weight of the smallest tag possible?
Mobile robots, yes. We are working with several AGV companies. How we see it is that when we are already tracking a lot of items or assets, or for example pallets, when we can give this information to the AGV will be, in fact, the whole thinking will move more dynamic, so that the robot can find the item wherever it is. The robots are going to be free from this fixed A to B point processes that they are mostly following today. So yes, we are doing that. We are working together with these AGV companies so that we are integrated into their softwares directly. And was it the size of the tag was the second?
Yeah, size and the weight.
Yes. So the smallest, explained, here is the circuit board, and the smallest we can go, this has all the sensors with it. Typically we have some 2 to 3 sensors in every tag. If we would leave those out, it goes very small, like the size of a coin. Most likely in industries, we are talking about a tag size of a matchbox.
The drones that you mentioned, it's a wheel drones, yeah? You mean it's a wheel robot, not a flying one? Yeah?
Yes, wheels, yes.
But do you think the flying one is also possible?
Yeah, we have been tracking drones as well. And in fact, that you will see on our website also, there is a flying drone, and you can see how we are tracking that. You can see that there is, because then you need this, also the jet coordinate. It's very critical to have that when talking about the drones. So yes, we are working on that space as well.
Great. Let's switch back to the software-related questions. Halima asked us, could we send a notification, alert-based notification via SMS? I think that's a question to Margarita.
Yes, absolutely, we can. We do support this feature, and I see no issues of sending in notifications not inside the platform, but to in mobile device, and getting, a faster reaction to an accident happening.
Yeah, I will add here that at Navigine site we do have MQTT brokers that you could subscribe and use and have all the notification momentarily. We have a webhooks, emails, any type of notification is possible. Any way to send this notification is possible. Okay, and one more question is, Margarita, you mentioned that there are some use cases where the existing solution on the market are not suitable. Would you be able to explain what is like specific example you have?
Yeah, so probably the most prominent example of such a case would be a plant with many metal constructions, and there the signal just doesn't really basically is being kicked from each of the metal tubes, let's say, and in that case, usually no matter, usually we're not able to meet the price, basically the project from the pricing perspective, because the increasing the number of infrastructure not always gives us the result that the customer actually wants to see in the system. And from the pricing perspective, also the increasing number of basically extended the infrastructure also does not meet the budget of the client. So basically, that is, I would say, mainly the projects connected with some heavy industrial cases.
Great. Let's go back to the beacon-related question. What are the power requirements of the beacons? Do the beacons have internal battery for deployment in remote locations where supply of the beacons may not be possible? It's a very good question, and I know that Tuka have an answer.
Yeah. Yes. Typically we are powering the beacons through power over Ethernet cable. So this CAT6 cable. That is also very low cost installation when using that. In that way, you get the power and also the data transfer in the same cable. Battery-powered beacons are used more and more. In one of the photographs there, or in the presentation you saw one beacon standing on a tripod. That's with battery. So of course, then the battery life, when it's a day or two. It's not, so it's like designed for events, for example, soccer event or some special event outdoors, but not for regular use. Wi-Fi installation is also what we use quite a lot. For example, in a factory, we can do cabling to most of the beacons, and then those ones which are hard to cable, but there is power, we can use Wi-Fi connection and just power them from the socket there.
Okay, I think not the last one. Zeros asked us, hello, you mentioned geofencing a static beacon. Have you geofenced a beacon on the mobile equipment for proximity use cases? And I think that Martina is now answering this question.
Sorry, what was the question?
Yeah, the question is about, is the beacon static? Is it possible to geofence a static beacon, or could it be like movable? Yeah.
Okay. Well, by design, the beacon is static. Although, let's say, if it was used for mobile purposes, like when we use mobile beacons with integrated power and Wi-Fi connections, even then around the soccer field, we would place it statically. So that's the idea. But then again, we do have the radius controls. We define areas around the beacon. We can create a geofencing circle around it to trigger entering, maybe exiting the area. That kind of controls are there.
Okay,
Yes.
and let's make two last questions. The first one is, what other sensors does the tech have? Maybe we could add here the panic button, mentions that, and the light sensor.
Yeah.
And one more question, can it be any interference between two separate networks?
So different, typically what we have is we have always the movement sensor, because that's what we use to optimize the battery life also. Then we have the LED. I would say 90% of the tags has LED. They have a buzzer, and also a button. And then for sensing, we have magnet detection, we have temperature, and of course then the power detection, so that we can monitor the battery power there. Those are what we have as a standard in almost every tag. You need to make a custom tag to not have those, let's say it in that way.
Great. Okay, I think that's it. We do have questions which we unanswered, but we will send all the answers in an email. No worries. As well, I think soon the recording will be available. I wanna say that it was like a great time. I see a lot of questions, which is good. And thank you all attendees. Thank you speakers. Hope we will have we will continue our conversation, and we will answer all the questions that our attendees give us. And yeah, so I think it was quite good. So maybe a few words at the end of our webinar.
Yes, so thank you very much about this opportunity to work with you guys, and also a little bit tell about what kind of systems we have done and what are the key benefits of this ultra-wideband Noccela solution. So thank you for this opportunity.